All right, I'm back. I'm realizing I need to go at a little quicker pace for the amount that I get for my videos. All right, so we're working on questions 17, 18, and 19 of the stoichiometry review. So how many grams of HI, so this iodic acid, are produced when 12 moles of hydrogen react with excess oxygen? So we're going to put our 12 moles of H2 out front. And to go from moles of H2 to moles of to HI, we're going to have to do a mole ratio, so we need to make sure that this is balanced. So there's 2 hydrogen here, which means there needs to be a 2 out here. That makes the I 2. There's already 2 I, so we have 1 and 1 on these 2 sides. So we're going to multiply that by our mole ratio. Moles of HI are going to go on top because we want grams of HI in our final answer. And then moles of H2 are going to go on the bottom because we want that to cancel out here. So when we look at our coefficient, H2 is 1 in front, and HI has a 2 in front. So our second step is going to be to go from moles to grams of iodic acid. So to do that, we're going to multiply by the molar mass. So the molar mass is given to us. It is 128 grams of HI per 1 mole of HI. So remember, that is always 1 mole. And so we're going to do this in our calculator. 12 times 2, because remember, this 2 divided by 1 is 2. And then we're going to multiply that again by our molar mass. 128 divided by 1 is 128. So we get a final mass of 3,072 grams of iodic acid. Next step, we have how many grams of water are produced when 3.6 moles of oxygen, so this is O2, react with excess hydrogen. So remember, that first step is going to be a mole ratio to go from moles of oxygen to moles of water. And our second step is going to get us to grams. So we've got grams of H2O. So we need to balance the chemical equation. So we've got 2 hydrogen here, 2 here. We have 2 oxygen here, but only 1 here. So we need to make this a 2. When we do that, we now have 4 hydrogen. So we need to make this a 2 as well. And now we're balanced. So we're going to do our mole ratio. So moles of O2 go on the bottom because we want that to cancel. Moles of water go on top because we want to get that as water as our final answer. So in front of O2, we have a 1. In front of water, we have a 2. So now we've got our mole ratio down. Now we're going to, since we're at moles of water, we can multiply by the molar mass to get to grams. So the molar mass of water is given here, so 18 grams of water is equivalent to 1 mole of water. And using our calculator, so 3.6 times 2 times 18 gives us 129.6 grams of water. All right, last question for the purple section. So we have how many grams of ammonia are produced when 5 moles of hydrogen react with excess nitrogen? So we've got 5 moles of hydrogen. Same steps, mole ratio to go from hydrogen to ammonia. So we've got moles of hydrogen that are going to go on the bottom, moles of ammonia on top, so that's NH3 on top. And we are going to have to balance this equation. So we have 3 hydrogen here. So to make this even, we're going to have to do 3 and 2. So now we're going to have 6 hydrogen on each side. We've got 2 nitrogen here and 2 here, so this becomes a 1. So if we look at our coefficients, NH3, we have 2 moles of NH3, 3 moles of H2. So our next step, now that we're at moles of NH3, we're going to multiply by our molar mass. So it's given that there are 17 grams of NH3 for every 1 mole of NH3. And when we do the math here, we're going to do 5 times 2. Divide that number by 3 for our mole ratio. Then we're going to multiply it by our molar mass of 17. So we get 56.6 repeating grams of NH3. We're going to quickly skip down to our gold level. So how many grams of ammonia are produced when 14 grams of hydrogen react with excess nitrogen? So we get 14 grams of H2 reacting with excess nitrogen to get ammonia. So it's the same reaction we just did. So we've got a 3:1:2 ratio. So first step, we're going to go from grams of hydrogen to moles of hydrogen. So to do that, we have to divide by the molar mass. So this is H2, so remember it's 2.02 grams for every 1 mole of H2. Okay, now that we're at moles of H2, we have to do a mole ratio to get us to moles of ammonia. So we do moles of ammonia on top because that's what we want. Moles of H2 on the bottom, we're trying to get rid of. So 3 goes on the bottom, 2 goes on top. Those are those coefficients in front. And then our third step is we're asking for grams of ammonia in our answer. So grams of NH3. And it tells us that if we're going from moles of something to grams of something, we're going to multiply by the molar mass. So that means that 17 grams of NH3 is going to be over the 1 mole of NH3. All right, so in your calculator, you're going to take 14 divided by 2.02, multiply by 2, divide by 3, and then multiply by 17. Get an answer of 78.55 grams of ammonia. All right, next question. How many grams of NaHCO3 are needed to react with 78 grams of CH3COOH? This is baking soda and vinegar. So if you remember back to the balloon lab, these are all 1-to-1 ratios, right? We can count this as a polyatomic ion. So that helps quite a bit. So we've got sodium, 1 on this side, 1 on this side. We've got 1, I guess you could call this a chaku or something like that, on each side. Then we've got 2 hydrogen, 1, 2 on this side, 2 on this side, 1 carbon on each side, and 3 oxygen, 1, 2, 3. So this is just 1, 1, 1, 1, 1. So we're going to start out with 78 grams of our vinegar. I'm just going to call this V for now because that makes it a lot easier. We're going to multiply that by, so it looks like we're going from grams to moles, so we're going to divide by the molar mass. That means the molar mass goes on the bottom. So 60 grams per 1 mole of vinegar. That's going to get us to moles of vinegar. We're going to do our mole ratio to get moles of baking soda. So that means that we need moles of baking soda on top. We'll call that B, and moles of vinegar on the bottom. Look at our balance equation, it's 1-to-1. Then we're going to multiply, now we're at moles of baking soda, multiply by the molar mass of baking soda, which is 84 grams of baking soda per 1 mole of baking soda. All right, so we do 78 divided by 60, multiply by that 1-to-1 ratio, it still gives us the same thing. Then we're going to multiply by 84, which is the molar mass of the baking soda. 109.2 grams of our baking soda. So that's the NaHCO3. There we go. All right, next step. How many grams of magnesium bromide are needed to produce 231 grams of magnesium chloride? So we have 231 grams of magnesium chloride. We are going to do 3 steps for this one. It's a gram to gram. So to go from grams to moles of magnesium chloride, we're going to divide by the molar mass. So we need to figure out what magnesium chloride is. We did this earlier, I think. So we did 24.31 plus 35.45 plus 35.45 gives us 95.21. So that's dividing by that. This is magnesium chloride. That's 1 mole of magnesium chloride. All right, now we're going to do our mole ratio. So magnesium chloride to magnesium bromide. And if we look, they're 1-to-1. So 1 mole of magnesium bromide is needed to create 1 mole of magnesium chloride. All right, and then finally we're at moles of magnesium bromide now, so we need to multiply by the molar mass of magnesium bromide. Whew, that's going to be rough. So we've got 24.31 for magnesium, plus each bromide is 79.9, so we got to do that twice. So 184.11. So we're going to multiply by 184.11 grams of magnesium bromide per 1 mole of magnesium bromide. All right, calculator, help us. So 231 times, 231 divided by 95.21. So we're dividing by the molar mass, multiplying by the mole ratio, which is 1, so we get the same thing. And then we are going to multiply by the molar mass of magnesium bromide, 184.11. And we get 446.69 grams. Grams of magnesium bromide. Hopefully we saw that all in there. All right, last two questions. We'll wait until next time.